I'll use visuals to explain how RepeatedKFold works. Think of it like repeatedly shuffling a deck of cards, your data, and dealing them into several hands, folds, multiple times. Each deal represents a different repetition. We have 12 data points. Imagine these as 12 unique cards in your deck. This tells me how many hands to deal in each shuffle, 3. Think of each hand as a separate test set. The remaining cards will make up the training set for that fold. This tells me to repeat the entire shuffling and dealing process twice. So, I'll shuffle and deal the cards 2 times to get different splits each time. This is the Sklearn function I'm using to do this repeated shuffling and dealing, RepeatedKFold cross-validation. Because I'm shuffling and dealing 3 times per shuffle and repeating this 2 times, I get a total of 3 times 2 equals 6 different folds. Each card, sample, will be in approximately 4 out of the 6 training sets and 2 of the 6 test sets. It's roughly equal, not perfectly equal. I get different arrangements of cards in each hand each time I reshuffle, meaning different training and testing sets in each repetition. This helps me get a more reliable estimate of my model's performance. That's why we repeat the process. I'm using Sklearn's RepeatedKFold, which is a powerful technique for model evaluation. It repeats K-fold cross-validation multiple times to give you a more reliable estimate of how well your model performs. This helps to reduce the variability that can come from a single K-fold run. It's like doing the experiment again and again to make sure your findings are consistent. This means I'm splitting the data into 3 groups. NSPLITS equals 3, for each cross-validation fold. Then I repeat this process 2 times, NREPEATS equals 2. This setup gives me more confidence in the assessment of the model. I get a total of 6 folds because it is simply the number of splits multiplied by the number of repeats. 3 splits * 2 repeats equals 6 folds. That's 6 different ways of training and testing the model. Each data point will be used to train the model exactly 4 times. This is because for each repeat, 2 repeats, the data point is in the training set for 2 of the 3 folds. 2 repeats, 3 folds 1. It's a neat way to ensure that each data point contributes fully to model training. I set the number of splits in my K-fold cross-validation to 3, meaning I'll divide my data into 3 folds for each iteration. The number of repeats is set to 2, so I will repeat this entire 3-fold process twice. Think of it like doing the same experiment twice with slightly different data splits each time. Because I'm using 3 folds and repeating the process 2 times, I will generate a total of 3 times 2 equals 6 different folds. That's 6 separate train test splits for evaluating the model. With 2 repeats of the 3-fold process, each data point will be in a testing fold approximately twice. It's not exactly twice for each, because of how K-fold works. It aims to distribute them fairly, but it is not perfect. In each of the 2 repeats, each sample will be in the training set for 2 folds. 3 folds total 1 testing fold equals 2 training folds. Therefore, across both repeats, each sample will be used for training in 2 times 2 equals 4 folds. I see that statement D claims that Sklearn's RepeatedKFold uses the same training and testing data splits in every repetition. But that's incorrect. The whole point of repeating the K-fold process is to get different splits each time. This gives you a more reliable picture of your model's performance because you're not just relying on one set of possibly unrepresentative splits. Think of it like this: if you only tested your model on one small group of people, you couldn't confidently say how well it works in general. This statement says that, with RepeatedKFold, each data point in your dataset will show up in about the same number of testing sets. That's mostly true. RepeatedKFold aims for a balance, but because of the way K-fold works, it's not perfectly even. The number of times each sample appears in the test set will be close to the number of repetitions, which is 2 in this case. Statement C claims that every data sample will appear in precisely 4 training sets. I'll show you how to figure this out. We have 2 repetitions and 3 folds per repetition. In each repetition, a sample is used in the training set for 2 of the 3 folds. 3 minus 1 equals 2 folds. Since we're repeating the process twice, the total is 2 repetitions, 2 training folds per repetition equals 4. So, yes, this statement is also correct. This is simply a matter of calculation. 3 folds per repetition multiplied by 2 repetitions equals 6 total folds. The calculation, 3 n underscore splits, asterisk 2, n underscore repeats, equals 6 is straightforward. I'm using RepeatedKFold, a technique in machine learning, to assess how well a model performs. I have 12 data points. RepeatedKFold will split the data multiple times to create different training and testing sets. This gives me a more reliable evaluation than just using the data once. That's the key idea here. I'm working with a small dataset, just 12 samples. This impacts how many times I can reasonably split the data. This parameter tells me that in each round of splitting, I will divide my data into 3 distinct parts. 2 parts for training the model, and 1 for testing. Think of it as 3 different folds, each with a unique testing set. This parameter instructs me to repeat the entire splitting process twice. Each repetition is independent, meaning that I get completely different data splits for each of my 2 repetitions. This helps to account for any random variations and gives me a more robust model assessment. This is the overall method I'm using. RepeatedKFold is a specific way to perform cross-validation, a technique that improves the reliability of machine learning model evaluations. It's like evaluating the model from many different angles. This is the first time I execute the data splitting. I create 3 folds, splits. This is the second execution of my data splitting process. Again, I create 3 completely different folds. These folds are different than those I generated in iteration 1. These are the 3 individual splits that are created during each iteration. Think of each fold as a separate experiment. Each has its own training and testing sets. These are the next 3 folds, coming from the second repetition of the splitting process. This is true. I have 3 folds per repetition and 2 repetitions. Therefore, I generate 3 times 2 equals 6 total folds. Simple arithmetic. This is also true. Because of the way RepeatedKFold distributes the data across folds, each of my samples will end up in the testing set roughly the same number of times, around 2 times, as many repetitions exist. Correct. I have 2 repetitions, each with 3 folds, splits. In each repetition, a sample appears in 2 of 3 training folds. 3 minus 1 equals 2. Because there are 2 repetitions, every sample appears in the training set 2 times 2 equals 4 times. Exactly. This is false. Absolutely not. The whole point of repeating the process is to get different data splits in each repetition, to make the model evaluation much more reliable. The ultimate goal of all this is to evaluate how well my machine learning model works. Using RepeatedKFold gives me a more accurate and robust evaluation that I can trust. I'm using RepeatedKFold, a technique in scikit-learn that repeats K-fold cross-validation multiple times to get a more reliable performance estimate. It's like doing the experiment several times to check for consistency. I have 12 data points to work with. Think of these as 12 different people we want to study. I'm splitting the dataset into 3 groups for each round of cross-validation. It's like dividing the 12 people into 3 teams for testing the training. I'm repeating the whole K-fold process twice. We're repeating those team assignments for a more comprehensive study of the 12 people. Since I have 3 splits and 2 repetitions, a total of 6 different tests will be performed. 3 splits asterisk 2 repeats equals 6. Each person will participate in training 4 times. That's because with 3 splits, each person will be left out of 1 split in each repetition. 2 repetitions, 3 to 1, equals 4 training sets. Each person will be tested about twice, because we are performing the split testing process twice. It's approximately 2 because of how K-fold works. It won't always be exactly 2 due to the randomization, but it will be close. I'm using different random team assignments each time I repeat the experiment. This is crucial because it helps avoid biased results. It's like shuffling a deck of cards before each experiment to avoid repeating scenarios.